And finally, the concluding presentation for today and this session, this day and this conference is by Stanislav Kaniukov, representing Prime Group. This sounds like a lot of fun. Thank you very much. Thank you for this honorable right to close this conference with my presentation, but I'll take a sudden turn. I will try to get real into the field of applications, and I will share with you some projects that we did based on space imagery to extract data about what lies underneath the water. I wanted to hide this slide, but yesterday foreign colleagues asked, what do you do? What's your line of business? We are a system integrator. In fact, we're implementing infrastructure projects in the IT sector, starting from designing to support. We were founded in 1999, so by now we've reached the stage of decommissioning of our systems. In 2003, a decision was made by our shareholders to pursue geoinformatics, GIS, and remote sensing. I am pleased to say that we were pioneers in delivering resolution better than 1 meter to our customers. QuickBird 1 is the satellite that is defunct by now, no longer in use. This is a trend of how imaging capabilities have been changing. Improvements on the technical side, on the one hand, linear resolution and georeferencing accuracy, while a number of spectral bands keeps expanding. We started with panchromatic, near-infrared and RGB, but the recent generation platform features crazy amount of spectral sensors. For Worldview 3, this is traditional sets that Worldview 2 had, plus a bunch of infrared related channels, dedicated channels for atmospheric correction. And the next diagram, and so I showed on the next diagram the ratios of the past and now. I cut off some of the wavelengths because the proportion got disrupted. So some of these bands were set up to address certain tasks, for example, violet and near violet, or the coastline. There are specialized bands to do proper atmospheric correction, plus there are combos of bands that can be in numerous combinations, helping you do any task you need. Many speakers talked about vegetation, forest, agriculture, yield and harvest forecast, mining, prospecting of minerals. So I'd like to tell you what kind of experience we had with projects in the water area. Satellite bathymetry, the near ultraviolet channel on top is the land, at the bottom is the water area, waterway. So we will go through the entire spectrum from infrared to ultraviolet. This is how the area looks in the infrared. This is how it looks with the visible red, green, blue, and then we add the coastline band, and it looks like we don't see the water, it's just the bottom. These are very good images, but these are promotional images which Digital Globe provided to promote and popularize this service.
Bathymetry is a very interesting subject. Why? Because it has a lot of advantages. Like financial aspect is much less costly than a traditional conventional method. Temporal aspect, production-wise, you can cover more areas for less time. Bureaucratic aspect, it's a localization of people and traditional conventional methods of deployment of people and permitting. If it is a foreign state, there are problems with the borders, and some areas you understand that you won't be able to get anything by conventional methods. Additionally, there's a security aspect, because the coastal waters have small depths and low risk of damaging the vessels and people who do this work. Satellite bathymetry starts to develop actively by our foreign partners. Maximum depth achieved by them was 35 meters in the area of Caribbean, in the water areas which are shown usually in beautiful Hollywood movies with blue water. More realistic values would be down to 20-meter depth in the Persian Gulf. This region is the leader in the bathymetric satellite coverage. Almost the whole coastal area is covered by the data received from the satellite. These data have been verified, and the quality of bathymetric data has been confirmed by field tests. And these beautiful tests, of course, must be used in Russian coastal waters, and the values we can get here and the need for such data is huge. Just an example for you, we have a port in Ust-Lug. It's a signature project for us. New cargo gates to Europe from Russia, and the port is connected by a navigable canal which is ramifying. One side goes to St. Petersburg, another side goes to Estonia. Between these two canals, the territory of the bay that people know nothing about, there are data from 1920s when the Red Army was making holes there, putting cord-based depth meters there, and putting in these values in the log, this information, which is important, and the administration of that port is asking us for this information. But so far we cannot do this by other means. We don't have Red Army people working there anymore. That is why satellite bathymetry. Let's try this. We achieved an agreement with the Central Mapping Agency from St. Petersburg, who are responsible for creation and updating of the marine maps, to do the experiment where partially we do this work based on satellite data, and our materials will be verified by bathymetric field tests. We were selecting for a while where this section for the experiment will be. We were choosing sites in Baltic Sea and Caspian Sea, next to Derbent, and in the area of Volga Delta we wanted to try different places, even went up north to Khatanga, Azov Sea, but eventually we decided on the Vyborg port, from Vyborg port to Vysotsk port and to Vikhrevoy Island, beyond which vessels go into the deep waters. The problem started right away. We failed to choose one image for the whole area of work. You can see the images were selected from different years, and in the middle we used GUI, which doesn't have this coastal band, but actually it was even for the benefit, because eventually we could really compare what is used by multispectral data and traditional set of data, and what results we can expect from all of these sets. As a result, we took an image. An operator excluded the all land area from the data that would be then processed. Then we did atmospheric correction to minimize the distortions because of the unevenness of atmosphere. We used a module at core from RTS Imagine. I'll just explain that we for a long time are using RDS, and in future, when new specialists will come, we'll gladly convert to photo mount and do atmospheric correction using domestic products. We have thematic products. We are photogrammetric product. It's unlikely that you will be able to do this work. But atmospheric correction, we have broad spectrum work, but I understand that atmospheric corrections can also be done in photo mode. We're all for domestic producers. And later on, in a specialized mathematical algorithm, we managed the weakening of the signal when it goes through the water, starting from the border of transition of water versus air. And as a result, we got a rastrum geotiff image with the size of pixel of 50 centimeters, which contained information about depth. And it was clear that these are relative values, which can be recalculated into absolute values, knowing the wind parameters and tidal parameters at the time of image acquisition. Also, we have plenty of stations who can provide this information in real time almost for navigation. Another problem, whereas initially we thought that we'll have information up to 5 meters accuracy, eventually it turned out that the depths that we could get, from which we got the reflected signal, was only 2.5 meters. As a result, the rastrum values were interpolated into isobat layer with 20 centimeter step and 50 centimeter depth lines. And you can see what we came up with. Red and blue are the areas where we managed to get data after processing, and why red and blue? Because these are the data which are the navigation colors for that areas. And the next step will be the comparison of these results, acquired results, compared to what we have there based on field tests. Next slide shows what is really there out of real values which were tested and measured for these coastal waters. Narrow navigable canal and the place of parking for vessels and the turnaround area next to the ports. So there are very few crisscrossing with the data acquired by satellite materials, and we select only 8 sections where we had this crisscrossing and analyzed the data that we acquired. As the comparison showed, for depths over 1.8 meters, we start to see huge deviations of the measured and calculated data. For less depths, we managed to find up to 4 points for which we calculated the differences in depth using the calculated methods and the field test methods. And conclusions are not really rosy. The maximum values we can acquire would be 1.8 meters for the equatorium, for the Finnish Bay waters, because of the circulation of water. There's a lot of sedimentation which comes from the delta of the Neva River, which can be seen even from the orbit. The 42 centimeter is the error, which is quite high here, and specialized ultraviolet band, coastal band, is quite critical about the quality of water. So it works well in clean waters, and when processing it's good, but for Russian waters unfortunately cannot be used for the benefit because there's none. And as a result, because the mapping company is responsible for navigation maps, which are used for the safe navigation of vessels, such values are unacceptable. This method is unacceptable for Russian waters for update of marine navigation maps. We can increase the precision of measurement by using the high quality source data. Like for instance, if we did some do acquisition in a quasi-online mode, when a person was there who could say that we have an ideal water there, there is no storm, equal surface, no waves, nothing is growing underwater, then let's do acquisition tomorrow. Maybe then values would be better and we would have used it again, especially nowadays when the level of interaction with operators has reached high level and we can really make an acquisition for the next day after the request. Maybe it's quite pessimistic, but we had another project for the Russian Academy of Sciences, and there they used regular data without the coastal canal and band, and they got very good result. Russian Academy of Sciences got the concession from the government of the Republic of Egypt to do underwater archaeological work next to Alexandria. Why underwater? Because the level of water has been raised by 7-8 meters, and most of the old town is underwater now. The area of work was about 30 centimeters, depths from 1 meter to 40, and the decision was made that for the coastal waters, in order to create maps for the area, we decide on the areas where the underwater exploration will be done. Because of the limited resources, we had to maximize the efficiency of this resource to achieve the maximum result. We decided to create maps for the coastal areas based on the remote sensing data, space satellite imagery, and for lower depths we will use special mapping vessel. We were asked to select an image for this area along the coastal line, and we looked at everything available since 1999, since the launch of ICONUS. We were not limited in time because 1,000 years have passed since then, and 15 years passed since then. It doesn't really matter. The main criterion for us was the existence of waves, the transparency of water, and no sun spots. And we selected a picture from QuickBird from 2017. 2013, I have a very good picture of COMSAT 3 of our coastal line in Alexandria, Hader. Hader is not that far away from Alexandria, but COMSAT doesn't see anything underwater. But here the image is a bit improved, even for the to the detriment of the coastal line to see better the underwater part. And as a result, this data and space images were uploaded into the Russian Academy of Sciences system, where along with the old maps, which were digitized from the 17th century, with the modern navigation maps and the results of measurements, we have done the analysis and selected the area where we'll do scuba diving and exploration underwater of these coastal waters. The result was very good. We found ancient port structures, old wave breaker that was the virtual border of this port. In the ancient times, some artifacts, places of sunk ships, and there is still some potential left because the work continues and our scientists count on new finds and new achievements here. That would be it. I have one request for you on bathymetric explorations. Maybe we're not the only ones who did such work, and maybe somebody else tried to measure depths using the materials of remote sensing data and satellite imagery, and I'm prepared to discuss your results, to learn what you came up with and compare it to our results. So you have something to say, I'm all ears after this conference. Thank you very much, Stanislav.